So, hello porters, this is Mr. Kane. I'm here to talk to you briefly about why ice floats on water. I'm going to focus primarily on math and showing work, but that's what this is about. So, quick topic. Last week we talked about density in class, so we did some demos showing what would float on water and what wouldn't. A variety of surprising things floated, while a variety of other things sunk. I think that if I'm going to highlight things that were important, is this. I'm going to highlight the fact that density is usually measured in grams per milliliter or in grams per cubic centimeter. The big difference between these two is that milliliters is usually used when we're dealing with fluids, and cubic centimeters is usually used when we're dealing with solids. That's not a hard and fast rule. You'll not see that followed absolutely everywhere, but that's the general consensus. It turns out it doesn't much matter because water has a density of 1.00 grams per cubic centimeter, but also has a density of 1.00 grams per milliliter. So it doesn't matter which way we talk about it, the number is going to be exactly the same. Anything that's more dense, like ethylene glycol, will sink in water with a density of 1.09. It sinks a little slowly. Gold would sink to the bottom a lot faster. Anything less dense, like balsa wood, 0.16, would float in water. The equation down here is probably the most necessary part of this slide for the math part. Density is calculated as mass divided by volume. So you've got to know your mass and your volume, usually in grams in milliliters or grams in cubic centimeters, and you can divide them. All right, moving on here. Okay, let's get a pen out. All right, the way I usually coach people to do this is to do something called the guess method. That is to say, not to actually guess at the problems, but guess as an acronym, standing for givens, unknowns, equation, substitute, and solve. Okay? So that means that what I would do is I would start out by writing some of my givens here. I would label my givens. Mass is equal to 6.50 kilograms. Now I'm noting here that I'm also given a volume of 13 centimeters cubed, and they're asking for what's the density. Okay, these are my givens and my unknowns. One reason why I like coaching to write these down is that then you get a chance to look at A, how many sig figs there are, and B, you also take a moment to look at the units. I'm noticing here that the 6.50 kilograms is not written in the sort of units that I would like it to be in. I want it to be in grams, so I'm going to rewrite this as 6,500 grams instead. Excuse me. I don't think that that's got the right amount of sig figs in it, and there's two ways to deal with that. One is just to write it so that I see that there's 3 sig figs, or the other might be to write it as 6.50 times 10 to the third grams. Either way is okay at this point, because both of them have 3 sig figs. All right, so that's my givens and my unknowns of my guess method. The next step is to write down an equation. So I'm going to write down density is equal to mass over volume. Usually I like writing down the equation because it's a nice idea to start manipulating the equation now with algebraic tools rather than to plug numbers and units in and then do it. Fortunately though, I'm trying to solve for density, and that's what this equation solves for. So I'm going to write over here density. I'm going to substitute, which is my first S. I'm going to write density equals, and I'm going to find my mass. I think I'm going to write down the 6.50 times 10 to the third, just because that's the one I happen to pick. Notice I'm putting my grams in. Yeah, that is ugly. I'm going to erase that real quick. Try that one more time. And then I'm going to put my 13 centimeters cubed there. So after I've substituted, usually what I try and coach is check on the units. Neither unit cancels, grams per cubic centimeter. That means that my units at the end after I solve will be grams over centimeters to the third, which makes sense because I'm trying to solve for density, and those are the units of density. I'm going to take my 6,500, I'm going to divide by 13. The calculator says the answer is 500, so I'm going to have 500 grams per cubic centimeter. Again, something I'm coaching at this point in the year is that your reflex at the very end should be to look at Sig Figs. Remember, we had 3 Sig Figs with our original value for mass and only 2 Sig Figs for our original value for volume. That means that I only want the least amount, which is 2. So I want to make sure that this answer is completely understood to be 500 grams per cubic centimeter with 2 Sig Figs. So I'm going to rewrite it in scientific notation. And that's going to be my answer. All right, I'm moving on to the next problem here. I know this says sample problem 3, but I forgot to renumber them. I like this as my second sample problem. It says here that we've got a mass of a cube of 25.0 grams. It says that the density is 2.00 grams per milliliter. And they're asking us to find the volume of the cube. All right, I'm going to write the equation again. And again, the equation, there's only one in chemistry right now, density equals mass over volume, so it's not like that's going to be difficult. The difficult part is this: I want to solve for volume, and this equation solves for density. I like to coach again to do the algebra on letters like this, our symbols, rather than plugging in our numbers and our units. Let's see. Variety of ways to solve for V here. The one thing that I want to coach is to be sure not to just try and divide by m or multiply by m to get rid of the m, because v is in the denominator here. We want to get v back into the numerator. I think the most common way that has been expressed today in class is to do this. If we multiply both sides by v, we move v into the numerator. And then we want to get v by itself, so we'll divide both sides by d. So v is going to be equal to mass over density. So I've got my givens and my unknowns written down. I wrote down an equation, and I algebraically manipulated my equation to solve for v, so that now I can substitute my mass of 25.0 grams divided by my 2.00 grams per ml. Again, going back to the coaching part, check your units, see what cancels. Grams and grams cancels, leaving me with 1 over milliliters, which is milliliters. So when I take my 25 and divide by 2 in my calculator, I'm getting a volume of 12.5 milliliters. Again, I'm hoping the reflex at the end here is to check Sig Figs. The original mass had 3, and the original density also had 3, leaving me with an answer with 3 Sig Figs at the end. So I get 12.5 mils. I'm going to do one more problem. If you think you've got the flow of the guess method, you might want to press pause here and then see if you wrote things down in a similar fashion to me. Otherwise, here we go. The density of a block is given as 0.500 grams per cubic centimeter. The volume of the block is said to be, now I'm thinking that they're giving me 3 measurements, so I can just show my math here. I think that's the most efficient use of my space. So I take my 6, multiply by my 12, get 72. 72 times 10 is 720 centimeters cubed. I see 2 Sig Figs with my 6. I see 2 Sig Figs and 720. So I'm thinking I'm doing pretty decent here. And we're looking for mass. Let's see, where do I have room for this? Density is mass over volume. I think I want to get mass by itself, so I just have to multiply the V away from both sides. So I get V times D is equal to M. So now when I substitute, I'm going to take my V, which is 720 centimeters cubed. I'm going to multiply by my 0.500 grams per cubic centimeter. Again, coaching about units here. Centimeters cubed is on the bottom and centimeter cubed is on the top, so it cancels, leaving me with units of grams, which is what I'm looking for. I'm looking for a mass. So 720 times 0.5 is going to give me 360. And again, if I'm coaching reflexes here, at the very end, we want to be looking for Sig Figs. So I'm seeing 3 Sig Figs in the number 5.500, and I'm seeing 2 Sig Figs in the number 720. Now that came from this that had 3, 3, and 2 Sig Figs. So 2 Sig Figs is right. I'm seeing 2 Sig Figs in my answer, so 360 grams seems like the right answer. All right, I hope that's helpful. If you got questions, check with your chem teacher.